On the video.
Ready? You do realize you're speaking now, and it's sending it out.
Oh, hello. Welcome. Hi, my name is Julie Swanson, and I'll be talking about binary today. So, first thing I gotta do is let's just get this over with real quick and actually explain what binary is. Binary is in a way, it's kind of like a computer technology. Computer language. It's usually used for binary code represents text in computers. So let's just get into it and say what binary actually looks like. It's pretty much ones and zeros. Like, no joke. That's all you see. And I don't know where there I am. So ones and zeros, so it's really, oh, that's a really big zero. So it's ones and zeros pretty much. So let's just get into this. Hold on, let me, Okay, so let's get this over with. Pretty much binary is what you would use to find out what your IP address would look like. So let's start off simple with 178.20. Ooh, I just covered my decimal. Pip. Okay. Dot. Oh, I'm using the wrong one. I'm not even looking at the right thing. Woohoo, this is great. This is all live. I'm doing great. I can't. Huh? Oh, really? Oh my goodness. I think I'm shaking more than I should be. Oh my God, I can't do this. Oh my God. I guess it's a black screen on mine. There it goes. Okay. Sorry for the technical difficulties real quick. So let's get back to where we once were. So pretty much binary is what some people don't actually understand, but it actually looks like this. It's all ones. Dot one. Oh my God, I'm shaking so bad. Oops, I lost count. 11, 12, 13, 14, 15, 16, 19, 19, 20, 21, 22, 23, 24. And then usually this one would be all zeros depending on what this is. So when we actually go into this, so we are going to find something real quick. Let's see if I can write down something. So usually that's supposed to be a 7, but I guess that works. 100 point, let's go with 16. And usually this slash right here will tell us how many zeros we need in ones. That's supposed to be a circle, but I can't apparently do this right. So now that we have our IP address, we can actually go into testing. So there's 4 slots, and each one depending on what your slash is. So I have /28. So I have 1, 2, 3, 4, 5, 6, 7, 8, which is 1 slot. And then let's go 9, 10, 11, 12, 13, 14, 15, 16 is another one. Dot. Oops. 17, 18, 19, 20, 21, 22, 23, 24. Just another one. And then we're on our last one, which would be 25, 26, 27, 28, and the rest are zeros. So that's where the /28 comes in. And this is, now that, since we have our last section, right here. Okay, doing great. And so then, now we're going to do this. So now that we have this, we have 28. We have, 64, 32, 16, 8, 4, 2, and 1. So after that, now we're, since there's 8 of these, so we're just going to put 1, 2, 3, 4, and 0, 0, 0, 0. Alright, so, and then we're just going to solve from this. So 16, which, is the original number that was right here, so we're going to go over here and put 16, because that's what it equals. And the rest are zeros. Whoa, hey there. This thing is so sensitive. And that's how we get the 16. Oh my goodness. Alright, let's get rid of all this. I might be, oh, hello. Alright, that works. I know I'm going a little fast, sorry about that. Alright, so I know I kind of went fast. I should have probably explained this in the beginning. But the slash can actually, the lowest number that it can go is pretty much 4. It's not common, but you can go that low. Usually the more common one would be /8 and not /4. Because there's 8 slots total. So let's not be an eraser right now. And let's stick in. So the lowest one you can do for is slot 8, and then the highest would be slot 32. It's not possible to do 32 because there's only 32 numbers in there, so I wouldn't advise having 32 as one of the main numbers because I don't think it's possible. So let's, whoa, hey now. Okay, there it goes. All right, so let's go back over here. And like where I was doing before, that's not the number I was looking at. So let's get over here. Okay, so I'm probably jumping around, I'm really sorry about that. And I'm also off screen. My partner's dying. Alright, so all of this, probably should have done this in the beginning. I'm really, really sorry about that. So that's 192. I know that doesn't look like a 92. Okay, there we go. 2. Okay. Alright, so what this would look like in binary would look like this. So let's get this down. And then 1, 0, 1, 0. Rest are zeros. Whoa, that didn't come out right. Alright. So then 1, 0, 1, 0, 0, 1, 0. Okay, so there we go. So this number up here is actually what this is. So it's the same thing. Alright, and then, okay, my mouse, I lost it. There it goes. Okay. So I lost connection for a little bit, sorry about that. Can you click on it? Can you click on it? No? Okay. I guess I'm just going to stick with that then. So then, let's see about this. Okay, this, so after this we have the, so this is binary. This is the what? Okay. Alright, so it's decimal, binary, and then we have the subtext. So it's 25.25. That's supposed to be a 5. 0, 0. Ooh, that's supposed to be done. Alright, so that's the ooh, hello. Subtext. Whoa, hey. My mouse just doesn't want to stay where I need it to be. Oh my goodness. Stop panicking. Alright, so that's what we're going to do right now. What I showed you guys before is how you actually get the binary, which is the one in the middle, and the subtext is what you would usually get after that. So, whoa, that's not what I wanted. 255 is actually what, usually these will stay as 225. These two you solve by having the middle. Oops. Just added another line there. In a little bit, I'll actually have my partner explain something a little more different than what I'm doing. Probably a little better than I'm doing right now. Whoa there. Okay. You know, I think I'm just going to actually let my partner do the rest of this. Are you ready? Okay, I'm going to pass over my mic because I'm really sorry that I suck at explaining what binary is. So here you go. Whoa.
How do I put this on? Here we go. Yeah, alright. Alright, so what we're going to be doing is hexadecimals, another way to do binary, and kind of an easier way to do it. So the way well, first binary uses a base 10 system. So hexadecimals use a base 16 system. So since hexadecimal is a base 16, and to not get it confused with normal decimals, you're going to want to use subscript when you're doing hexadecimal and write 16. So it's going to look like this. So right now I'm just going to write a random hexadecimal number. So that's what a hexadecimal number would be, has a base 16. So that's 10 in hexadecimal. So let me show you how hexadecimal lines up with actual decimal. And it looks like this. Oh, yeah, hexadecimal right there, decimal right here, and right. Okay, yeah, that's an A. Yeah, it looks like a fish. Let me just finish that off real quick. Alright, so, you start at 0, and then 1, 2, 3. We're just going to go up to, let's say, 15, if we could try to fit that for decimal. 13. 14. Oh, yeah. Okay, alright, that's enough. Okay, that's 14 and 15. So for hexadecimal, what that looks like is going to be 0, 1, 2, 3. It's normal up until 9. So 4, 5, 6, 7, 8, 9. Now after you get to 9, you use letters. So to represent 10, we have A, and so forth. So B would be 11, C is 12, D is 13, E is 14, and F is 15. So with that, 0 to 9 represents 1 through 9, or yeah, 0 to 9 represents 0 to 9, and A through F represents 10 to 15. So let me show you an example of how hexadecimals can be used to make binary numbers. So right now we just have the hexadecimal number. Let's do A332. So to put that number into binary, we first do the A. So what A would be, like I said before, A represents 10. So to get 10, you would have 8, or first off, let me put this up here real quick. This means 1, this is 2, this is 4, this is 8. If there's a 0, that means the number isn't counted. So for A, since that's 10, we would have 8, skip 4, have 2, skip 1, A plus 2 is 10, and A is 10. So that's the first binary number. And then for 3, it's just normal 3. So you have 0 at 8, 0 on 4, 1 at 2, and 1 at 1. Same thing, because there are 2 3s. And then for 2, you just have 1 at 2. So 0, 0, 1, 0. So that's an example of converting a hexadecimal number into binary. Let's do another example. Let's do like F879. So for F, like I said before, that's 15. So now we open up more numbers. So instead of having 4, we add 2 more. So this number is still 1, still 2, 4, 8, 16, 32. So since F is 15, we would do, or actually, let's get rid of this right quick, because with hexadecimals you convert it into 4 binary numbers, so we actually don't need this. My apologies for that confusion. So for F, we could actually just get 15 by having 8, 4, 2, and 1, just adding all those up. Because 8 plus 4 is 12, 14, and then 15. So we could just have all 1s to represent that. And then 8, just 1, and then 0, 0, 0, 2, we know that one already, 0, 0, 1, 0, and then 9, 1, 0, 0, 1. So that's like kind of an easier way Like, some people are more comfortable using decimals to convert to binary. Some people are more comfortable using hexadecimals. And I kind of think hexadecimals are a bit easier, so that's what I use, but you can use whatever you want. So that was an example on how to use hexadecimals to make binary numbers. Please like and subscribe, and leave a comment to know what content you want next. I'm out. That's it, Mr. Smith.